When you think of a snail, most of you would probably think of the slimy creeping creature. Something like this. Maybe exactly like this. However, if you look at marine snails, there are tons of unique looking ones. You might think land snails look boring. Maybe not so for marine snails. Which is why I'm showing you these different snail shells. You know, maybe one of them looks interesting to you. But that's not exactly the case for the topic of this video though. What I meant by that is, the snail I'm gonna talk about might look typical. You could argue it looks boring, but their lifestyle is definitely unusual. This is Janthina, the rafting snail. So, let me bring up the question. What exactly is Janthina? Janthina is an actual snail, gastropods, which also means they are mollusks. They are classified in the Gynogastropoda subclass, which is quite literally the most generic snail group. Most living snails are classified in this subclass, so nothing special so far. Intuitively, I would talk about the order next, right? But for Janthina, it's not easy to do. Why? Because we are not sure where to put them in the order rank. Even worms listed as Incertae. And if you didn't know, worms is typically the page you go to when you want to find out about marine creatures taxonomy. Oh, and also, in case you didn't know, Incertae basically means uncertain placement. So yeah, for now we could just move on to the family level. In the past, Janthina is classified in its own family, which was Janthinidae, which is fair enough. They are quite unique after all. However, nowadays they are classified in Epitonidae family, which is the family of wentletraps, a group of benthic snail with staircase shell that feed on sea anemones and corals. Although I haven't talked about the lifestyle of Janthina yet, I did say they are the rafting snails, which means they live near the water surface, and that lifestyle is the complete opposite of wentletraps that stay on the bottom of the ocean. I'm gonna talk about why they are classified in the same family later when I talk about their evolution. Because, spoiler alert, Janthina most likely evolved from wentletraps. But anyway, Janthina is a genus name. The name Janthina derived from Janthinus, which is the Latin word for violet blue. Pretty self-explanatory because if you've been looking at the screen, you would notice that their color is violet, which is also why they are sometimes called the violet snails. I've been using the word they because there are several species in this genus. Different authors could assign different number of species, but in general, there are 5 extant species of Janthina. If you're looking at them as a whole, their distribution is quite widespread around the tropical and subtropical ocean. The common Janthina, which is Janthina janthina, is also quite widespread of course. However, if you're looking at specific species, their distribution can be quite limited. For example, Janthina exigua can mostly be found around Australia and New Zealand, while Janthina pallida can mostly be found in the Mediterranean Sea. Next, let's talk about their morphology. First, let's talk about their general morphology. Janthina's cell doesn't have an operculum. That's the lid of a snail shell, by the way. The reason is, Janthina doesn't retract into their shell. To be precise, they cannot retract into their shell. Why? Because they need to keep their raft intact. Their raft consists of bubbles enclosed in a hardened mucus. And what's keeping all of this in shape is their propodium, which is the front part of their foot. We'll talk about the functionality later. Because their body is always outside their shell has sinus on the outer lip. This notch right here. This enables their head and the anterior part of their body to comfortably rest here while still being outside of their shell. Now let's take a closer look at their head. They have forked cephalic tentacle on their head, which is quite unique because the generic snails that people know have completely separate tentacles on each side. Another unique trait that you could notice when looking at Janthina's face is the fact that they don't have obvious eye. Though, it is reported that Janthina could react to motion and light, which means they probably have tiny eyes that couldn't be observed with our naked eye, or perhaps another form of photoreception. One last thing to look at. This. What you are looking at are their radulae, their teeth basically. And yes, unlike most snails that keep their radula inside, Janthina's oral cavity turned inside out, exposing their radula on the tip of this proboscis-like structure. Just like other snails, these radulae are supported by odontophore, which is basically a cartilage. When everted, the odontophore will be stretched and the radulae will spread out and erect. When retracted, the radulae will clasp together, hence able to be used to grasp and rasp prey. Now let's finally move on from their head and take a look at their shell. Let's look at it from the aperture side, that is, the side that have the shell opening. All of them have dextral shell, which means if you position it this way, the aperture will be on the right side of the axis. Now you should notice the fact that, first of all, their color has a different shade of violet, and second of all, their shape is also different from each other. And yes, this is how you mostly identify a snail species, by looking at their shell. Maybe you noticed that, but you couldn't put it into words what exactly makes them different, so let me help you with that. First, let me introduce the parts that you should be looking at. The opening is called aperture. The periphery of aperture is called lip. When you look at them from the side, notice how they seem segmented. Each of these quote-unquote segment is called whorl. The thing separating each whorl is called suture. The whorl where the body resides is called body whorl. The rest of the shell is called spire. And that's all you need to know to understand what I'm gonna explain. Let's start with Janthina pallida first. Pallida means pale because they are pale. Their aperture is big, sometimes bigger than the body whorl. Their spire has moderate height. The shell is relatively smooth. Their sinus aka outer lip notch spans the entire outer lip but the shallowest of them all. Now onto Janthina globosa first. This one also has a big aperture, but has a taller spire compared to pallida. The basal spire whorl is significantly taller compared to the rest. Their sinus also spans the entire outer lip, but V-shaped and deeper compared to pallida. Next, Janthina. The spire is usually low, and the body whorl is typically wide. Their sinus is supposed to span the entire outer lip, by the way. The specimen in this image is damaged. The problem with Janthina is, they are so widespread and they have a lot of variation to the point that it's not easy to assign a diagnostic trait to them. Honestly, it's easier to check whether a specimen is any of the other 4 species, and if it's not, it's probably Janthina. Another thing to note though, Janthina is the biggest extant Janthina, reaching 50 mm in diameter. So if it's a big specimen, it's most likely Janthina. Anyway, the last two, Janthina exigua and Janthina umbilicata, have a tall spire, especially compared to the other 3. The easiest way to differentiate these two is by looking at the relief of their shell. Janthina exigua have a really strong and prominent relief, while Janthina umbilicata have a relatively smooth shell. In this image, it looks as if Janthina umbilicata have lighter coloration, which should make it easier to differentiate them from Janthina exigua. That is true, but only for bigger individuals. Smaller individuals have darker coloration, so the coloration is not exactly a reliable tell. Each species also has different average size, but of course, that is not exactly reliable as the sole diagnostic trait because, they don't start their life with maximum sized shell. So even the biggest species can be quite small as they grow. But yeah, those are the 5 species. Next, let's talk about their lifestyle. But before that, Janthina are neustonic, meaning they live right around the water surface. Like I've been hinting since the start of this video, Janthina are rafters, and they make their own raft. First, they raise their propodium above the water. Then they fold it, hence entrapping the air. This propodium has mucus gland, which will secrete mucus of course. The mucus will trap the air, forming a sustainable bubble. It is enclosed in a mucus that could harden to some extent after all. The process takes about a minute, and they form a bunch of this bubble, sticking them together, and that's the raft. The raft will float above the water while they hang upside down underwater. Each species tends to make a different raft, by the way. For example, Janthina tend to make larger and messier raft, while Janthina pallida tend to make smaller and more uniform raft. But yes, all of them just floats, somewhat without any particular direction, leaving their fate to winds and waves. Oh, by the way, if the bubble pop and the raft sink, they will also sink, and then they die. But now you might think, how do they seek prey exactly? Well, they simply don't. They stumble upon a prey stochastically, and when they do bump into one, they eat. They mainly feed on Velella, but also Porpita and Physalia, which are floating hydrozoans. So yeah, evolutionary unrelated creatures adapting a similar lifestyle, but one eat the other. Classic. Oh, by the way, there are some articles that stated the violet color of Janthina helps in subduing prey. That sounds questionable, doesn't it? But some reports stated that the violet dye, called janthinin, actually have an anesthetic effect, at least towards Velella. When coming in contact with Velella, they secrete this dye periodically to anesthetize the Velella as they eat it. With something, huh? Now let's talk about the reproduction. The Janthina are most likely protandry hermaphrodite, meaning they start as male, but then morph into female as they grow old. That's determined by which sexual organ is developed and active, by the way. In Janthina globosa, all of the big specimens are female, and that's how we know they are protandry hermaphrodite. Though, as far as I know, we aren't sure whether all species is protandry hermaphrodite, but at least that's the norm for their entire family. A 2018 publication showed that Janthina could potentially change their reproduction strategy based on the population structure. For example, Janthina pallida can be simultaneous hermaphrodite, meaning an individual can both be male and female. In this case, both male and female sexual organs are developed and active. So yeah, still a lot to discover. Males don't have penis. Instead, they produce sperm packet called spermatozeugmata. They can swim around and they will try to seek females. Swim into said female, then fertilization happens. Females will lay eggs inside egg capsules, and these capsules will be attached to the underside of their raft. Except for Janthina, they brood their eggs inside their oviduct instead. Eggs will hatch into veligers, which is basically like tiny snails, but they have a ciliated structure called velum, which they use to swim around. Janthina's veliger do have operculum, by the way. They lost it as they develop into adults. Oh, by the way, this veliger phase is not unique to them. Many other aquatic snails also undergo veliger phase. But honestly, that makes it even more interesting how they somehow evolve into this rafting life, especially considering they evolved from benthic snails. How and why did that happen? Well, let's talk about that. The closest relative of Janthina is most likely Alora. This is based on morphological comparison, because the shape and sculpture of Alora shell is similar to fossil Janthina. Oh, and yeah, we do have several Janthina fossil specimens. And yes, we have been making the connection between Janthina and Alora for quite a while. The oldest Alora fossil predates the oldest Janthina fossil, so that checks out. However, like I hinted earlier, Alora are benthic snails, while Janthina, as you should already know if you have been watching to this point, are rafters. And now the question is, how? Well, the most supported hypothesis, at least currently and as far as I know, is the egg mass hypothesis. Forming egg mass string together with mucus is a common thing for Wendell traps. So, quite literally, it runs in the family. A modification of these egg capsules make them buoyant, hence they float. In a sense, making your egg floats can be beneficial. Think of it like this. Imagine a chicken laying egg. You could quite easily grab the egg, right? So could many other predators. But imagine if after the eggs are laid, they hover. Now you couldn't easily grab those eggs, right? Well, to be fair, chicken egg needs to be incubated, so this wouldn't exactly work even if it could magically happen. But snail eggs don't need to be incubated. Over time, they add bubbles into their eggs to make them float better. As time goes by, it becomes the norm, and that's how they live their entire life. That hypothesis could make sense, but of course it's still a hypothesis. A better answer could potentially be produced in the future as we learn more about them. Maybe as we discover some more fossil records. But for now, let's just learn what is known. And that's all for now. Oh, by the way, Janthina are not the only rafting snails. Those in the genus Reclusia also make rafts, but that one is not as specialized as Janthina, and only females make rafts together with their eggs. Anyway, enjoy your day.